Ladies and gentlemen, we are getting near the end of PACE 1130. Woohoo! So, as I am finally recording this at the very end of March 2020, our nation, yea, our world, is embroiled in a coronavirus outbreak, and it has become an exponential growth, which actually exponential growth is a lot of times what logs are used to deal with, because there's exponents. And as a result, our school has been closed for 2 weeks, heading into our third week now. So I have spent a lot of time trying to get our school students up and running with their paces and making math lessons for them and chemistry lessons. And so it's kind of put me a little behind in doing these video lessons for these math paces, since this is not a course that we are currently using in our school. I'm just doing this for you. All right, so let's dive in here. Let's get this pace done, and then while all my kids are home for the next probably 2 months, I hope to be able to finish these last two paces, 31 and 32, in fairly short order, unless the world blows apart or I die of the coronavirus. Let's hope that doesn't happen, but I am in that older category, so I've got to be careful. All right, page 24. Now, there are faster ways. I will give you this, that you could just use your calculator and solve this without having to use logs to get the answer, okay? We're going to kind of strike it down the middle. I want us to get some more practice using logs and anti-logs to get close to the right answer, okay? But we're not going to use all the tables and charts in the back. We need to know how to use our calculator. We need to know the rules for logs, and that will prepare us for when you get to college, and let's say you go into engineering or something, advanced math, and you actually do use the logs and anti-logs, all right? So I realize we're kind of making this a little harder than we have to, but our goal here, listen, our goal here is not to get the answer so much as to see how the logs and anti-logs work to help us get to the same answer. Okay, so it's just showing us another method, and we want to get comfortable with it. So the book explains what this formula means. A is the interest earned if you invest P dollars, the principal, all right, and we're going to invest it for a certain number of years in this. I want to point out to you here on page 24, because when you need to do the homework, there are three different formulas, so you do need to notice these formulas. One is if you're doing it annually, the other is if we're doing semi-annual compounding, so in other words every 6 months the interest is calculated, and then they have one where it's compounded quarterly, and I think you will need to use, I'm going to need to use the quarterly. We have two problems with semi-annual and two problems with annual. Okay, let's do, I want us to actually take the problem on the bottom of page 24, because in checking the answer that they got, we get a different answer. So I think they're wrong, and I'm not sure how they got that answer, but if you check it with your calculator, which we're going to do right now together, we're going to get a slightly different answer than they got, okay? But we're following the correct procedures, so this should work. All right, notice what we did. We plugged in for this example problem 300 for the principal. It says the interest rate is 5.5% and it's semi-annual. So the percent becomes 0.055. We move the decimal twice. We're dividing by 2. And then this out here, it becomes the same denominator. So this is 2 times however many years. For this problem, it was just for 1 year. All right. Now here's where logs come in. Now we're going to rewrite this whole thing in logarithmic form. So now we can say the log of A equals the log of 300, and then because these are being multiplied, we would say plus, and then because we have a quantity raised to a power, we take this exponent, put it in front, 2 times the log of, and then we can just go ahead and add this, So this becomes the 0.0275 plus 1. Now, if we were not using the calculator, we would have to do some fancy things, you know, to look up just the 0.0275 and whatever. All right, we're not going to do that. Let's use our calculator. All right, clear. So on mine, I have to hit log first, and then I'm going to type in 300, hit equals. We're going to carry it out to 4 decimal places. So I get 2.4771. And I think that's what they did get in the book for that one. All right. Now here I'm going to take log, type in 1.0275. All right, hit enter. And we get 2 times 0.0118 or 118. I'm going to carry it out to 4 decimal places, okay? 0118. Now, I don't understand. When you look at the solution guide on the bottom of the page here, they're not getting that. But this is the correct answer. Sometimes sometimes the fallible authors of the PACE have occasionally made mistakes, and I think we found one of those here. It always used to drive me crazy 40 years ago when I was a student doing the PACEs, probably some of those very same PACEs, and they would have errors in the examples, which would then throw me off trying to do the problems. That's probably never happened for you. Here's one where we caught it, so let's talk about it. All right, so now I'm going to go ahead and take that 0.0118 times 2. So 0.0236. We're going to add that to the 2.4771 plus 2.4771. Whoops, I multiplied it. That's not good. 2.4771 plus 0.0236. Are you doing this on your calculator? If not, get your calculator out and let's do this with me here, all right? Add these together. So we get 2.5007, and that is the log of A. So now we're going to go the other direction to find, well, what is A? Well, that means we're going to have 10 raised to that power, or on your calculator, you're going to say the second function of log, which on my calculator is 10 to the x power, and I'm going to type in 2.5007 equals 316. Okay, and they got 310, so I get 316.74 to be exact. They got 318.20. So somewhere, and I think it was, I recall, it was in here that they came up with a different number for some reason, and then that throws all the rest of that off, throws our answer off by a couple of dollars. Now, I went through and I resolved 7, 8, 9, and 10 just to see how close using the calculator comes to the answer that they get. And by following this method, okay, you should get within $1 or $2, maybe $5, but you should be really, really close. The exception is, I think they messed up again on problem number 10. Okay, so problem 10 says, calculate the principal that must be invested at 3% semi-annually to yield $2,500 in 10 years. I have to get a sip of water, I'm sorry. All right, so we don't know the principal, so that's the P. 3%, so we put in the 0.03, it's semi-annual, so that's twice, so we divide by 2. Now here, we're going to put the 2 up here times the number of years, which is 10. 2 times 10. So that's how they're getting 20, okay? We don't know P, but we know this is the interest that we want to get, $2,500. So the question is, how much interest do we need to put in initially? All right, so let's see how we're going to solve this using logarithms. So we're going to first rewrite this in logarithmic form. So the log of 2,500 equals the log of p. Now because these are being multiplied, we're going to say the log of p plus, and then 20 becomes the coefficient out front, times the log of 1.015. All right, here we go. Calculators out. Log 2500. Okay, let's see what you get. You go ahead and write it down, carry out to 4 decimal places, all right? Okay, don't look. You didn't do it. Aha! Do the math. Put in 2,500, hit the log button, or do it the other way first, log in 2,500, and tell me what you got. Okay, this is your homework problem. You need to help me. You need to do the work. Did you get 3.3979? Yay! Okay, now your calculator probably went further, but we're going to round it off to 4 decimal places. That's probably far enough. All right. Equals, we'll just leave this here. Now, let's do the log of the log of 1.015. Log 1.015. Okay, did you get it before me? Now round it off to 4 decimal places, so it's going to be 0.00 something something, right? All right, you should have gotten 0.0065. Now we're going to multiply that times 20, and that gives us 0.1293. All right, now we're going to subtract this from this 1293. Let me bring this over, minus 0. Okay. I probably could have done this just in my head, but I've got my calculator, 1293, and I don't want to have to borrow. All right. Okay. If you did that subtraction, you should have 3.4 digits equals the log of p. Okay? 3.2686 is what I got, equals the log of p. All right, so here's what we're going to do. In order to find the principal, we need to do the second function log, which would be the same as 10 raised to the power, okay? And then plug that number in. I get 1856 equals the principal. Now, yeah, somehow they get 1680, and I think they messed up right here. Somehow they got 0.0086, and it should be 0.0065 when you do the log of that. And then you multiply 10 times 20, and the rest of it follows through. So the answer key, I would argue for number 10 is wrong, and we got the correct answer. Aren't you glad you came to Mr. Anger for your math lesson today on page 2425? Woohoo! All right, I think we just have one more lesson, and you are done with this pace. Yay!